Alright, hello everybody, we're back. I'm so glad to see that you guys have your textbook. So if you haven't found it yet, it's under the course syllabus. Justin put it up on your class here, on your math class. So if you look underneath course content, course syllabus, if you click on there, you should have a link to your textbook, which will help immensely because this is going to get a little tricky. So I would definitely say read over Unit 2. This is covering fractions, and I'm dividing this lecture up into 2 sections. There's a fair amount of homework with it. The first homework that I posted was before you had the textbook, so I scanned the pages and downloaded them or uploaded them or whatever to the course content, so you'll have to view them that way. And then the second assignment for so this is for Wednesday, the 22nd is today's lecture. And then for Friday's lecture, the homework then is just listed by page number. So assuming that you're all able to get to the text. If for some reason you're not, let me know and we'll get that figured out. So be patient with me on this. This is going to be a little tricky to try to teach fractions without being able to write on the board. I'm going to try to play with this because apparently this has the ability. So we'll just kind of go with it and learn as we go. All right. Alright, so, and plus I do have, there's a couple video links. So again, view the PowerPoint. So you'll have 2 kind of links for these PowerPoints basically. The first one, always under course content or under the day, is going to be the original PowerPoint that I would normally just show in class. Those video links are generally always clickable, or at least cut and paste them. When I'm doing it on the YouTube, sometimes it doesn't work that way. So there are some videos that I did link to this. So fractions, you're looking at fractions as basically 2 different numbers. You're looking at a part and then the whole. Okay, so the part is what's always on top. Okay, that's your numerator, and then your denominator is the bottom, which is the whole. Okay, so it's basically a division problem. But that helps to look at it that way. All right, so this is just kind of a step-by-step approach to any math problem. You need to figure out what needs to be solved. What are they asking you? Sometimes, you know, highlight it, circle it, underline it, whatever, so you can figure out what you're trying to solve. And then you have all different pieces of the puzzle. Okay, maybe that's why I like math, because it reminds me of a puzzle. So you need to figure out, you know, what you're doing. Are you adding, subtracting? You know, what are you? Excuse me. What do you know? And what are you being asked to do? Know the rules for the problem. So especially with fractions, there's definitely different rules. For math overall, I think there's always different rules. And then double check your math. Work the problem backwards if you have time, meaning put the answer back into the equation. You know, double check it. Especially algebra is kind of easy to do. You can, you know, whatever you're solving for x, you know, put what you have back into the equation. And just kind of step back. A lot of times too, like, does it make sense? Okay, so just kind of take your time with that. Alright, so for example, here's your vocabulary part. So a numerator and your denominator. Okay, I'm going to play with something once. I'm going to see if this is going to work. Okay, so I'm going to take, actually I'm going to do a different color. Let's see what happens here. So your numerator, then we're going to do that 2, okay, would be your numerator, and then your denominator, whoa, is going to be 4. Okay, sorry about that. Kind of funny little mouse here. So your part is 2 and your whole is 4. Okay, so if you're talking about 2/4, which most of us should know, if we were to reduce that fraction, it would be 1/2. Okay, so we're just talking about vocabulary right now, so I'm not going to get too carried away. So those are the two parts of the fraction. When you're talking about a proper fraction, that's probably the more common one that you're used to, where your denominator is greater than your numerator. Okay, so like in the case of 2/4, that would be a proper fraction. An improper fraction is going to be the flip-flop of that. Okay, so that would be 4/2. Okay, so your numerator is greater. So, oops, I don't know why I think it's my crazy phone. So your numerator then is greater. So it's kind of top heavy, so it's improper. Okay, so your top is heavier than your bottom. One way of looking at it, it's going to tip over. A mixed number then is a whole number combined with a fraction. So a mixed number would be like 4 and 4 and 1/2. Oh my goodness, I need a lot of practice with that. Okay, so that would be a mixed number. So you have a whole number combined with a fraction. Alright, here is a video link. Okay, this is some basics, Khan Academy. This is about 5 minutes. Alright, and this is just basic explaining of fractions, so hopefully that can help too. Alright, so talking about equivalent fractions, like I mentioned before, so your 2/4 is equal to 1/2. Okay, so you're just kind of looking at the fraction in a different way. So you're looking at equivalent fractions. So it depends on how many parts to the whole that you're talking about. So for example, in the first picture, if you're looking at this as being a cookie or whatever, you have 1/2, so being the shaded area. So 1 part of the 2 being the whole, 1 being the part. Now for the second one, 2/4, you have 4 parts instead, and with 2 being shaded. Okay, so you have 2/4, 2 being the part, 4 being the whole, but it's equivalent, it's the same amount. Okay, same as the last one, 3/6. This time you've divided the whole up into 6 sections, okay, but you've shaded 3 of those, so the part is the 3 over the 6, which again is still equal to 1/2. So hopefully this is a lot of review, shaking the cobwebs off the old brain. Alright, so again I kind of talked about improper fractions where the numerator is larger than the denominator. So 16/8, okay, is definitely improper. You can look at that as a division problem. You can say 16/8 equals 2. Okay, is one way of looking at it. You could reduce it. I'm looking at this thinking for just a second here. So it's basically showing that 16/8 equals 2. 8 can go into itself 1 time. Also 8 can go into 16 2 times. So 2/1 then equals 2. Okay, so that would be a way of simplifying the 16/2. But if we're looking at something a little bit different, there's no real common number here, where before the 8 was kind of a common number. You could easily divide 8 into 16. We're looking at 11/8. So what we could do is, we know that 11/8, that 8/8 equals 1. Okay, so that's our 1, but then we have 3 left over. Okay, so we take 11 minus 8, and that is going to give us 3. Okay, so we can kind of look at it as bear with me again, my little magic pen here. So if we have 8 over 8, oh my gosh, and that equals 1. Okay, we still have 3 left over, okay, because 11 minus 8 is 3. So then we're going to have 1 3/8. Another way to look at this is if you were to take 8 times 1 equals 8 plus 3 equals 11. So that would be 11 over 8. Okay. Hopefully this is making sense. Hopefully the book can help explain it too, since we can't have conversations about it. All right, mixed numbers. Okay, a mixed number I already kind of talked about. That's a whole number plus a fraction. Okay, so here's a good way of looking at. We have 3 and 5/6. Okay, so we have 3 wholes, and then 5 are shaded over the 6. Okay. But if we were to look at that as an improper fraction, okay, we could take 6 times 3, okay, your 6 times your 3 equals 18, plus 5 is 23, so that's how you get 23 over 6, okay, or you can count, you've got, what, 6, another 6 here, that's 12, another 6 here, that's 18, 19, 20, 21, 22, 23. So 23 over 6, okay, because you have 3 wholes there. All right, what about adding and subtracting fractions? Well, you have to, one of the rules for this is that you have to find the common denominator, okay? You have to find a common denominator. So if you have a mixed number, you want to convert it back into an improper fraction. So we're just looking at this one for example. So the common denominator then is, this is described on page 46 in your textbook. The lowest common denominator is the smallest number or multiple that both of the denominators can go into. Let me say that again. The lowest common denominator is the smallest number or multiple that both of the denominators can go into. Okay, so we're taking a look here at 1/2 plus 2/3. Okay, so we look at the 2 and the 3. Okay, one of those can't go into the other one. All right, so we have to figure out, we have to find the common denominator. So if one number can't go into the other, multiply those 2 numbers together. So multiply your 2 times your 3, and that's going to give you your 6. So that's going to become your common denominator, right? Then you have to do what you do to one side. I'm going to try to write this one out again. It's going to take a little bit longer on the PowerPoint here, but I'm okay with that. So we have 1/2. Okay, and we're going to turn this into 6. So what we had to do is we had to multiply both of these, the top and the bottom, by 3. Okay, gosh darn it. Okay, so that's how we got our 3/6. Whoa. All right, 3/6. Okay, so we multiplied both the top and the bottom by 3, and then on the 2/3 we did the same thing. We had to figure out what did we do to the 3 to turn it into a 6. Well, we multiplied it by, oops, can I erase? Okay. So this was 3. So we had to multiply both of these by 2. Okay. Alright, so that gives us the 4/6. So now we have a common denominator. So now we're we're just going to take, like they did up here, the 3 plus the 4 equals a 7, and then 7, 6. Okay. Now, if we were to convert, how would we convert that back into? Let me see. I think I got my next slide. No, sorry. So if we had, let's just go back over here. 7, 6. So that's now improper. Okay. This should be a 7. If we turn this into a mixed number, 6 goes into 7 one time, okay, and then, so that's the same as 6 over 6, okay, and then we have one part left over, one remaining. 7 minus 6 is 1. So really, 7 over 6 equals 1 over 1/6. Okay, again, 6 times 1 equals 1. I'm sorry, 6 times 1 equals 6 plus the 1 equals 7. Okay. All right. Now, when we look at subtracting fractions, I like the eraser better. If we look at subtracting fractions, we again need to find a common denominator. Okay. So we have 3 fours minus 1/2. Well, we know that 2 can go into 4 2 times, so we're going to turn 1/2 into 2/4. Okay, we multiply both sides by 2, both the top and the bottom by 2 to get the common denominator 4. We had to take this, multiply it by 2, and now we have 3 minus 2 is 1, and we leave the denominator alone, just like we did with the addition. So we don't change. Once you've messed with it to get the common denominator, leave the denominator alone. Then you're only playing with the numerator. Okay. All right. So then we do the math there. Then we get 1/4. All right. Now's when it gets really fun. Okay. When we're looking at borrowing. Okay. When we're borrowing, we're subtracting fractions. Okay, so we have the same concept. We still need to have the common denominator. However, in this particular problem, we do. Okay, we have the denominator of 7. However, when we go to do this math here, we are noticing that our 2 minus 3, well, we can't do that. Okay, we can't take 3 away from 2. We don't have enough. So we need to change this number to a different number that means the same. Okay, so we have to borrow. Okay, so what we do here is we take 1 whole away from the 8. Okay, so 1 whole when we're working with 7. Okay, 7 parts basically. I know whole is the denominator part, but we're looking at 7 pieces. So another word or another number for 1 in this particular problem is going to be 7 over 7. Okay, so that's where we brought our, so we're changing this to this basically. Okay, so we have 7 over 7. Okay, so we've taken one of those wholes, 1, away from the 8. So this changes the 8 to 7. But now we're going to add the 2/7 to it. So we're adding the 2/7. Sorry. Okay. And that's going to then give us 9/7. Okay. Jeez Louise. This mouth is crazy. Alright, so I hope you can see that the 7 over 7 is the same as 1, so that's where the 1 came from. So the 8 turns into 7, then we add the 7 plus the 2, so now we got 9 over 7. So 7 and 9/7 is the same as 8 and 2/7. Now we can work out the math. Now we take the whole number, we take 2 away from the 7, that gives us 5, and now this is workable. We take 3 away from the 9, gives us 6, and then we have the denominator is the same as 7. Okay, So the book does, I think, a pretty good job of explaining it too. Thank you for hanging in there with me. All right, I think that's why I left the slide blank, because I have a couple different, another different example here too. Okay, let's see. So for example, this is on page 52 and 53 in your 53 mainly when you're talking about borrowing. So you have your first problem here of 17 3/8. Okay. Gosh darn, this thing's goofy. Okay, 17 3/8, and we're minusing 14. Oh, you know what? I'm gonna try. I wonder if this works better. I wonder if that's smaller. Ooh, look at me. Oh, good. Oh my gosh, you're even struggling. I tell you, you learn as you go. It's just life. Learn as you go. Okay. There we go. Wide marker, wide tip, fine tip. All right. So we look at this and we're like, okay, the 14 take away from 17 I can do, but I can't take 4 away from 3. So what am I going to do here? I got to borrow one whole one. So I'm going to borrow a whole one. So that's going to take the 17 down to 16. Okay. Now 8. I'm working with eighths. So I'm going to take 8 over 8. Not too much better than that part. 8 over 8. Oops. This would be so much faster on a regular whiteboard. Okay, and then I'm going to have to add that 3. That was supposed to be a 3. I don't think this works with my finger now. I was going to say I don't have a touch screen. So we're going to add 3. You guys are probably laughing at me or feeling bad for me. I hope you're feeling bad for me. I'm feeling pretty bad for myself. Alright, there we go. Okay, so basically I have now 16. Okay, I'm adding my 8 plus my 3. Okay, so I have 16. Bless me that that's 11. Okay, over 8. Okay, I hope you see how I did that. How I took a whole one. A whole one was the 8 over 8. Okay, and then I added it to the 3 that I had up here. So 11 or 8 is 16 over 11 over 8 is my new number. Basically means the same thing as 17 over 3/8. Minusing the 14 over 4/8. Okay, but I'll figure it out by the time I'm done doodling around here. And this should not be an equal. This should be just a minus. And now we have what? 16 minus 14, so we should have 2. Toledo, 2. Oh my gosh. And then 7/8. Oh, like I said, this should be in your textbook also. Wow. Holy Toledo. That was awful. I gotta try that too again. That's gonna drive me nuts. There we go. And then, what did I say? This is a 7. Oh, that's a pitiful 7. I think if you can use your imagination, well, you can see it. The other one was an 8. Okay. All right. So 2 over 7/8. Wow, that is crazy stuff. All right. Now, what fraction is largest? Okay. So we will have 1/4 or 3/8. Okay, that can be an example. And I cannot remember if I have a blank here. Gosh, let's take a leap of faith and see. Oh, nope, I don't. Darn it. So let's go. We're we're going to kind of look at which one is larger here again. Okay. So just ignore the writing on the top for right now. Which is larger, 1/4 or 3/8? Jeez Louise, I tell you. Okay, so I'm hoping that you're thinking that the first thing that we have to do to be able to compare these things is to find a common denominator. Okay, but you're right if you said that. Okay, so which is larger? So I'm hoping that you are thinking that our common denominator here is 8. Okay, so our common denominator is 8. Oh my god, I give up. I'm going to try one more time. Okay, so then I'm going to turn then my 1/4 over here to get it to be equal to 8, I have to multiply it by 2, right? So now I'm looking at, and I have to do the same thing to my top. So this is going to turn into 2/8, okay, because I multiplied both the denominator and the numerator by 2 to turn this to get a common denominator of 8. Okay, so obviously the bigger one is the 3/8. Okay, so you'd have the alligator. Oh my gosh, I can't even do that. This would be your bigger number. Wow. All right. Gonna try to move on. Try to stop drawing. Oh shoot. Fortunately, I can't go back. Multiplying fractions, you basically, that's probably one of the easier ones. You just multiply straight across, okay? Multiply straight across. You don't need to figure out a common denominator. So we had, the problem was on the previous slide, like I said, for some reason it won't let me go back, but we had, if we have a whole number, then we turn it into an improper fraction. So if we're looking at 1/2 times 2/3, we're going to go ahead and multiply straight across the 1 times the 2, which will give us 2, and then the 2 times the 3 is going to give us 6. So we're going to have 2 6, and we reduce that. We can divide both by 2, and that's going to give us then 1/3. Okay. All right. Now we are looking at when you're multiplying by a whole number. Sorry, I think we kind of skipped that part. So before our multiplying fractions, just straight across 2 halves, or I mean 2 fractions, straight across. All right, now we're looking at using a whole number. Okay, how do we do that? So we're going to take the 1/2 times the 6. We're going to turn the 6 into an improper fraction. Okay, that's what I was saying before. So you're going to take the 6 and you're just going to put a 1 beneath it. Okay, 6 over 1 is the same as 6. Again, you multiply straight across. 1 times 6 is 6, 2 times 1 is 2, 6 over 2, if you do the division, you put 2 into 6 3 times, so it equals 3. Alright, another YouTube video link to help you with multiplying fractions. I hope I'm not going too fast, but I don't want to like beat it to death either at the same time, because I know for some of you it's probably like, oh my gosh, she's killing me. It's kind of tedious, especially with the little drawing piece here. All right, division. Division's kind of fun. Division, you just flip it. Okay, so you have to always keep in mind though, keep the numbers in the right order. I have a lot of students, I always want to say patients, I have a lot of students that when they go to rewrite the problem, they turn the order of the problem around. Okay, so make sure you're just following it the right order. So you have 1/2 divided by 1/3. Okay, so you're going to go ahead, rewrite it as a multiplication problem. You're going to keep the 1/2 first, and then you're going to flip this part. Okay, sometimes I think they flip the whole thing, but just flip this part. Okay, flip it meaning flip it from the numerator to the denominator. Okay, flip it around. So you're going to take 1/3 and turn it into 3/1. Then multiply straight across. 3/2 or 1 1/2 if you reduce it. Okay, knowing that 2 goes into 1 one time with 1 left over. Again, I can double check that. 2 times 1 equals 2 plus 1 equals 3. All right, what about division? Okay, division this way. Okay, looking at it this way. So division with the dividing sign, or if you see it written like this, 1/2 divided by 2/3. Okay, that's the same as them being right next to each other. I think this is where people might get a little tripped up as to which one to flip. So you're going to flip up the divisor. You're going to flip this one around, flip this upside down. Okay, so you're dividing into 1/2. So your 1/2 stays the same. The bottom number flips, turns into 3/2, multiply straight across. All right. I kind of threw this one in here with simplifying fractions. Okay, so this is kind of one to look at. Your another way of looking at 30. I guess I probably won't go through this exact process, but this is one way of looking at it. If I were to break down 30, I could say it's 5 times 2 times 3, and I'll do a quick little, hopefully, a little kind of visual of 6 times 6 is also 2 times 3. Okay, and then the same thing over here. This is another 2 times 3. Alright, so if I were to simplify this, I could basically get rid of this, okay, and then I have to knock out one of these, and now I have my 5 over my 6. Okay, so 5, 6. The more likely way that I would probably do it is I would say, okay, what can be divided into both of these? I know that 6 goes into 36 6 times, and 6 can go into 30 5 times, because I know 5 times 6 equals 30. So that's why I said getting those multiplication tables down if you haven't. This is a good time to get those engraved in your head. But this is kind of another way of breaking this down or simplifying it. All right, here's a good one. This is something you're going to see in math and science both. So you're not just going to go over it this time, but you're going to go over it again in math and science. So how to, or science also, sorry. How to convert from Fahrenheit to Celsius and Celsius to Fahrenheit. Okay, that's part of your homework for part 2 of this fraction thing. So you may have to go back to it. It's done fairly well in your book. So you're going to take your Fahrenheit degree. So let's say you had 102, okay, for your Fahrenheit. So you're going F to C. F to C. So if you had 102, 102 minus your 32, I'm going to give you what? Hopefully you said 70. Okay. And then you're going to take 70 times 5/9. Okay. So 70 times 5/9. So it'd be what? 350 divided by 9. Okay. So If you used your calculator to figure out this part, that's okay. I'll be okay with that. We will be spending some time on long division, so you need to remember how to do long division too. Gosh, I hope we're back in the classroom by then, because that's going to be really hard to do with this crazy mouse. And then when you look at the other way, you're looking at Celsius to Fahrenheit, you're going to take your Celsius degree. So if you have, let's say, 39 degrees Celsius, you're going to times that by 9/5, and then you're going to add it to 32. So if you do the math properly, if you start with 102 degrees Fahrenheit, you should come to 38.89 degrees Celsius. Decimal there. Celsius. Okay. And then if you start with 39 degrees Celsius, you should get to about, well, it's 102.2. 102. I almost feel like if I don't hold on to the mouse as tight or something, I'm not sure. Okay. Dot. Big dot right there. 102.2. Alright, thanks guys for hanging in there. I think we just have one little slide left. Alright. This one here is a multiplication. If you have exponents, okay, you're just going to multiply straight across. You have 1/2 to the second power. That's basically 1/2 times 1/2 equals 1/4. Okay. I guess if you get stuck, you could convert it to decimals, but we'll have time to do that later. All right. Thanks for hanging in there. I'm so glad that you have your textbook to use as a reference now. Send me any emails that you have with questions. Also, Khan Academy is a great resource. And your assignment for this day, for Wednesday that I'm giving you, is not due until Friday. Okay. All right. We'll see you next time.